Good morning, everybody. Yes, we've done so far sections 1 and 3 of chapter 1. Today we've done some of this already. I said, because I don't know the way the book had it, but we floated in a more logical sequence. Today we're going to discuss sections 2, 4, and 5. And then next week we'll talk about section 6. Because I mean section 6 is totally different than what we're doing here. So that's what we'll look at today. Before we get started, I need you all to pass out and get one of these. Because today we're going to start talking about functions. Up until now, we've talked about equations. So up until now, we've had equations like so if I wanted you to find the value of y, I say if x equals 0, if x equals 3, and x equals -4. So if I gave you these, what would you do? Here's your equation. You're going to find points on a graph. So what would you do if I gave you this? Plug each of these into the x one by one. So when x equals 0, we get y equals 3 times 0 plus 2. And work it out. 3 times 0 is 0. 0 plus 2 is 2. So the point here is when x is 0, y is 2. And the next one, when x equals 3. Okay. Anywhere I see an x in the equation, I put a 3 in its place. Let's see. Why do I put parentheses around them? Yeah, if I didn't put parentheses around them, it looked like 33. So I put parentheses around the 3 because that's the number I put into the equation. So that's my input. So I work it out. Order of operations, do multiplication first. 3 times 3 is 9. 9 plus 2 is 11. So the point here is 3, 11. And the last one, when x equals -4. Anywhere I see an x, I put a -4. Positive times negative is negative. 3 times 4 is 12. Negative and a positive, different signs, so it takes the sign of the larger number. Answer is going to be negative. 12 minus 2 is 10. So that's what's going on here. When I give you a value, a function, an equation, I'm looking for points on that equation, on the graph of that equation, so I can just plot those and go. What quadrant is this one in? It's quadrant 1, because they're both positive. How about this one? Yeah, because you go left and then down, so you're in quadrant 3. The difference between this and a function A function has this notation. It's the same as we have earlier, except here, instead of writing y equals, I replace y with a function name. How is this read? Very good. F of x. That's how it's read. What it means is the function f with variable x. So f is the name of the function, and whatever's inside the parentheses is the variable in the equation. So the reason we use this nowadays is that once I define what the function is, for me to ask you to solve these, all I would have to do is that. This one means the function f, so I have to go to the function name here, f. Anywhere I see an x, I put a 0. So inside the equation, anywhere I see an x, I put a 0. In the next one, anywhere I see an x, since it's inside the parentheses, and here's the function name, I put a 3 in place of x. And the last one's the same thing. Here I go to this function. Anywhere I see an x, I put a -4. And you work it out the same way from there. Is there any limitations what I could put inside the parentheses? No. I could put equations inside there. I could put pictures inside there. So if I put what would you do there? Put a heart in place of x. If I put that inside there, what would you do? Yeah. Inside the equation, anywhere I see an x, I would put this in its place. So I have a 3, whatever's inside the parentheses, plus 2. So it doesn't matter what you have. As long as it's inside the parentheses, it goes in place of the x in the equation. Work that one out. What does this mean? What does this tell me? What is it asking me to do? Yeah, I multiply 2 to whatever this is. Order of operations says do what first? Special operations. So I have 2 times what is this? Well, this is the name, so I use this equation. In place of x, what do I put? A 3. Because whatever's inside the parentheses is my x. So I have 4 times 3 plus 5. Because here's the g of x, that's 4x plus 5. But the g of 3 is instead of x, now I have a 3. So it's that. Now I work it out slowly. Order of operations. Inside the parentheses, do this. 4 times 3 is 12. Inside special operations, 12 plus 5 is 17. Seventeen times 2. 7 times 2 is 14. 2 times 1 is 2, plus 1 is 34. So 2g of 3 is 34. Difficult? Do another one? Let's look at another one. Let's do this one. G of negative 2 minus 3 times f of 4. Wait, what's means? G of negative 2 minus 3 times f of 4. That's how you would read that. You have to look at, this is the language of math. We have our own words, we have our own symbols, we have everything. So you have to know how to read it and communicate to other math people. So go ahead and work it out. Yes, the question was, are we still using it? Yes, because once you define them, they remain, in this example, they remain the same definition until I redefine it. Until I redefine G and F, I'm going to use this equation. So anywhere I see a G or an F, I'm going to use these until I redefine them. Very good question. So again, we have G of X is equal to 4x plus 5, and f of x equals negative 2x plus 3. So in here, I use this function, and I put negative 2 in place of x. So I have 4 times negative 2 plus 5 minus. Now, whenever you have a minus in front of an equation, put that other one inside parentheses to separate it from that. So it's 3 times f, which is negative 2x plus 3. So it's negative 2. X is 4 plus 3. So we got to do inside this parenthesis first. So inside here, I have another parenthesis. So I read this one left to right. I got negative 2, negative times positive. Negative and positive is negative. 2 times 4 is 8. So I just did that first. Repeat the process. I gotta do inside the parentheses. I gotta do inside this one first. -3 plus 8. They're different signs, so 8 is bigger, so its answer is negative. 8 minus 3 is 5. -5. We can do something inside this parentheses. So +3 times negative. Positive times negative is negative. 3 times 5 is 15. We can't do anything else inside the parentheses, so we have to get rid of the parentheses. Positive times negative is negative. 4 times 2 is 8. Negative times negative is a positive. 15. Left to right. -8 plus 5. 8's bigger, so the answer is negative. 8 minus 5 is 3. $15 bigger, so the answer is positive. 15 minus 3 is 12. And you didn't want to say your answer. So it's again, it's the same stuff we've been doing. All we do now is we, instead of writing the equations down, we're referring back to function names. So yeah, you'll have much practice in there. All right, so let's move on. When we talk about functions, we have to first talk about the differences between a correspondence versus a relation. What is a correspondence? In the old days, correspondence was what they called mail. Did you send any correspondence? Did you mail me a letter? How does that work? When you mail somebody, okay, let's say we have two cities. Here's city A and here's city B. Now, person one in city A can send person A, I'll call this, I'll do 1, 2, and 3 also, make it easier for us. So person one in city A sends person one in city B a letter. Can person one send anybody else a letter in that town, in B? Have you ever received mass mailings, advertisements? So let's say this person is running for an office and he wants to send everybody a letter. Vote for me. That's correspondence. Person two only wants to send person one a letter. They're friends. Person three doesn't care about anybody. That's what we call correspondence. Now, does person one have a relationship with anybody here? Remember, think about what relationships are. When you're dating somebody, you have a relationship. If you're just going out there and dating everybody, you don't have a relationship. That's a relation is one person from A to one person of B only. So there's this person can only like number two. Number two only sends number one letter, so they have a relationship. Number one sends it to three people. He's just corresponding. There's no set rule for that person. Number three has nothing. So what's the difference between correspondence and relationship? Very good. That's exactly what it is. A correspondence can have multiple connections multiple connections. A relation can only have one sender and one receiver. Here's a good example. Students in a class versus teacher in a class. Students in a class. Is that a correspondence or a relation? I'll show you what this means. Here's class A, class B, and class C. Yes, it was a correspondence. The answer was correspondence. Well, let's go backward. Remember, correspondence can have multiple connections. Does one have multiple connections? No, this student only has one class. So that's a relation. Only one, right? The other ones have multiple ones. So these are correspondence. In the second example, you have student 1, 2, 3, and the teacher. Teacher 1, teacher 2. Well, let's say one teacher. This is a teacher of class A. So do the students have a correspondence or do they have a relation? They have a relation because they only have one connection. It could be the same node. So going this way, it's a relation. How about the teacher to the students? That's a correspondence. It's going this way because this person has multiple messages going out. So if you send and receive only one, you're a relation. So pretty much number one's monogamous, 2 and 3 are partygoers. There's another way we can look at this. We call this X and let's call this Y. Let's look at example A and example B. Is example A a correspondence or a relation? Why? No. But it is a relation. But here's the reason why. Notice what I said earlier, for a relation, you have to have one. So one person from A can only communicate with one person from B. So in other words, what it's saying here is as long as the X, if they're all different, if all the X's are different, then that's a relation. Because it all depends on what X does. So this is a relation. But if you notice in example B, all of the X's are the same, but the Y's are different. This is a correspondence. Because for all, remember, X is 2. Does X only have one Y that it goes to? For a relationship, X can only go to Y once. X cannot go to Y1, Y2. This is a relationship. This is a correspondence. Is that a relationship or a correspondence? Okay. Are there any duplicate X's? Here's a 2, here's a 2. Are they different? No, because they both go to 1. These are the same points, so it doesn't matter. All the other X's are different, so this is a relationship. Now, with respect to equations, it's much easier if I give you a graph of an equation. I'll give you 4 graphs. Is the first one a relation or a correspondence? Why? That's what I'm getting to. Perfect. Yes. This is a relation. How about this one? How about this one? And this one. If I give you a graph, these are actually all graphs of functions. This is y equals x cubed, y equals x squared plus y squared equals r squared, and y equals x. Don't worry about that. We're going to do that sheet I gave you in a second. We're going to fill up all these. Now, if I give you a function with functions or graphs of functions, use the vertical line test. The vertical line test says this. There it is. If you draw a vertical line, remember, vertical line goes up and down, through any point on the graph and it crosses the graph more than once, then it is a correspondence. And if it's a correspondence, it is not a function. You can put your cell phone away. It's not going to go away. It's like you needed a teddy bear to hold on to during class. What that means is let's look at any of these graphs. If I drew a vertical line anywhere, does it cross the graph more than once? No. So it's a relationship. That means if it's a relation, that means it's a function. Then the graph of this is a function. The second one, same thing. If I draw a vertical line, it doesn't cross it more than once. It's a relation, so therefore that is a function. In this one, I touch it pretty much twice everywhere. So since it crosses twice, it's not a relation, it's a correspondence, therefore it's not a function. So same thing as okay, that's a graph. Graphs are easy. But how would we do it if we had equations? Is that a function? Yeah. Because the way you test it, you look, can you find any x value that will give you more than one y value? Now, for any x I put in there, if I plug it in there, I know I'm only going to get one y. How can I be sure of that? What kind of equation is this? What kind of function is it? Linear, which means it equals a line. It's a linear equation. How do we know it's linear? Because there are no exponents or special operators on x or y. In other words, the x and y are just x and y. There's nothing different about it. How about this one? Is that a function? Y. Yeah, because for each x value I put in there, I get its own y value. In other words, x can I have two answers? Or let's see. If I put -2 squared, what is -2 squared? It's -2 times -2 is +4. If I put 6 in there, 6 squared, 36. If I put -6 in there, I get 36. Remember, this is my x and this is my y. Even though they get the same y values, the x's are different. That's okay. Since it's a squared function, it looks like this. So yes, it is a function. This is the vertical line thingy. Bless you. How about this one? Why? What about it? Give me an example. Remember, try to find two x's that the same x, or one x that'll give you two answers of y. You can always use tables to find values. Let's make it easier. So let's say x is 4. What number squared equals 4? How about -2? -2 squared is also 4, right? The same value x, different y's, so not a function. Because it has the same x's, but different y's, so it's not a function. You cannot have the same x's with different y values. This graph is what we call hyperbola. Looks like this. So it fails the vertical line test. graph that. To graph equations, you first have to find some points. Of course, the more points, the better. So let's pick for x's, let's pick some negative numbers. Let's pick 0 and some positive numbers, just to see how it behaves on all three of those. So we'll pick -2, -1, 0, 1, and 2. I want some negatives, I want positives. So if I plug in -2 inside here, what do I get? I mean, okay, make it easier. What do you see? Yeah. Is there an x value there anywhere? No. So all my y's are going to be the same. They're always going to be 2. It's called a constant function. It's always, no matter what x I put inside there, no matter what x I put inside there, y is always equal to 2. Because remember, y is equal to f of x. So in this case, no matter what x I put in there, y is equal to 2. So what does that graph look like? At -2, it's 2. At -1, it's 2. At 0, it's 2. At 1, it's 2. It's a horizontal line. If all x's, I mean, all the y's are the same, then it is a horizontal line. In other words, if it's a constant function, it's a horizontal line. So if I work backwards, remember I said it equals, the function equals wherever it crosses the y-axis. So if I gave you, that function, what's the equation? Very good. Equals 1, 2, equals -3. Because it's a horizontal line, that means all the y values are the same, no matter what x I put in there. Is it a function? Yeah, because it passes the vertical line test. What's x there? No. Yeah. X equals -2. So what does this number represent? That's the Y value, right? So let's look at here. What X value corresponds to that number 2? That one right there. So that one means X has to be -2. Because remember, these equal a point. If I give you a graph, that point there is -2, 2. How about if I give you that? Because what number does this represent? X equals 4. So when X equals 4, it goes to this point, and that point corresponds to 1. Remember, this is the Y value, this is the X value. This is the X value, this is the Y value. You have to know how to interpret a graph to be able to solve these. You have to go both directions. If I give you the X, you can tell me the Y. If I give you the Y, you tell me the X. Domain and range. The horizontal axis is what? It's the X axis. And the vertical is the Y. Domain is all possible X values. The range, all possible Y values. So domain is the list of all inputs. Those are all the X's you put in the equation. And the range is the Y values. It's what it equals. So in the first one, that's an equation of a line. What's the domain? Hmm. Because if you look at this line, it goes on forever and ever. So on the X, the negative side, it keeps on going. So it goes to negative infinity. And this side of the graph, it keeps on going to positive infinity. So the domain is negative infinity, comma, positive infinity. Or we can say that means all real numbers, which means this little R sign means negative infinity, positive infinity. What's the range? Mhm. It's the same because going down, it keeps on going all the way down to negative infinity. And it going up on the Y values, it keeps on going up to positive infinity. So negative infinity to positive infinity for all real numbers. How about the next one? That's called a quadratic parabola. Parabola. What's my domain? Yeah, this thing keeps on going further and further and further out. It goes to negative infinity. So it starts off at negative infinity. Likewise, on this side, it keeps on going to positive infinity. So it's all real numbers. What's my range? Can it be negative? No, since there's nothing down here, it can't be negative. Can it be zero? Yeah. Can it be positive? Yeah, it goes all the way to infinity. So what this one does, it starts at zero and goes to positive infinity. Or I can say y is greater than or equal to zero. Mm-hmm. Yes. If it, very good question. If it has a number that it is a solid dot, that means it can start and stop at that point. Then we use a bracket. If it was an open circle, then we'd have a parenthesis. That means we can't use, we go all the way close to it, but we can't use it. Then I'll give you one next example. How about the last one? It's an equation of a circle. What's my domain? Where's the domain? Which axis? Again, I can't help you unless you guys give me some input. If you're lost, if you're stuck, I need to know. It's the x-axis. So how far does it go on the x-axis? Where's the start? Where's the stop? Yeah, it starts here and it's here. So it's -3 to +3. And since I can use them, I put them in brackets. How about my range? Yeah, start off at -3. I always start with the smaller and go to the larger. And next week, we're going to learn how to write all these things in either this form or that form. What's my domain and range there?
Oh, wait.
So this is -1, -2, -3. So the domain starts at where? Yeah, remember, domain is the X values. So if you have a graph like this, tell me where it starts and stops. So it starts at -3 and it ends at 4. Can I use this one? Is it a open or closed circle? Open, so it's parenthesis. That's how I distinguish on 4. It's a solid, so I can close that one. If it's closed, that means it's if it's a solid dot, then it's a box. If it's open, then it's a parenthesis. How about my range? Same way there. Let's draw a horizontal line and a horizontal line. From where to where? We'll get that inequalities later on. But again, this one's at -1, -2, so it's at -3 to +4. And it looks the same way there. So for whenever you look for the domain, put a box up vertical up and down at both ends. If it doesn't end, it goes to infinity. And then the range, put the highest and lowest and see where they cross the X and Y axis. That's the easiest way to do it. All right, so that's for right now. That's way. Get your sheet I gave you. Let's start off with the constant function. A constant function, where C is a number, C is any number. Remember, y equals, let's say y equals 4. So I'll go to 1, 2, 3, 4. Put a dot. Since there aren't any X's there, we have a horizontal line. So wherever the C is, you just draw a horizontal line. What's the domain and range there? The domain, horizontally, it goes to -infinity to +infinity. And the range is simply that value C, whatever that number is. It doesn't go up or down. It stays at 1 line. The next one. Y equals X. When X is 1, Y is 1. When X is 2, Y is 2. When X is -1, Y is -1, and so on and so forth. What's the domain? What's the range here? Remember, they're both going forever. It keeps on going forever, both directions. Up and down and left and right. So it's negative infinity, positive infinity. The absolute value equation. We're going to spend more time on this in the near future. But pretty much, does everybody remember what absolute value does? It makes whatever's inside there positive. So you're always going to have a positive number. It's the same as the linear equation. There's no exponent or anything. So in the positive side, when x is 1, y is 1. Likewise, when x is negative 1, y becomes positive 1. So it's a v. It starts at the origin. So the domain and range, what's the domain? Negative infinity, positive infinity. Yeah, because it keeps on going forever and ever. How about the range? The range is horizontal, right? So what's the lowest it can go? And the highest? So it goes from 0 to infinity. Oops, I should put that there. I'll come back to this one last. The quadratic equation. Because it has an exponent, it is no longer a straight line. Whenever you have a number up top here, it is no longer a straight line. It now curves. The domain and range. Yeah. X's are from negative infinity to positive infinity because they keep on going both directions. How about the range? The lowest it can go is 0 because you cannot have a negative answer. So it could be from 0 to positive infinity. Because it keeps on going to positive infinity. Cubic function. An exaggerated form of the cubic function looks like this. What's the domain? What's the range here? How far does it go to the left? And it goes to negative infinity. And to the right, it keeps on going to positive infinity. Likewise, going up and down, it goes from negative infinity to positive infinity. These last two, actually the second one and the last two, the linear equation, the quadratic, and the cubic function. That's giving us an indication of what we're looking for when we deal with equations. Linear equation. There's no exponent, so it only crosses the x-axis once, which means we only have one solution. When we talk about solutions in equations, we talk about where it crosses the x-axis. So whenever you hear somebody say an equation say solve this, we're actually looking for the x-intercepts. quadratic equation. It has a 2 up here. So that means our graph could actually look like this. So we can have at most 2 solutions. That's what the exponent tells us. We can have 1 solution, or we can have no solutions. Just by looking at the equation, you can tell me how many solutions we're going to have, or we're supposed to have. Cubic, how many are we supposed to have there? 3. 1, 2, 3. But that's the most we can have. We can have 3 solutions. We can have 2 solutions. We can have 1 solution, and that's it. That's as far as we can go. We can have 3 solutions, 2 solutions, or 1 solution. Then once you get comfortable, start looking at these equations. You can tell me a lot of stuff now. You can tell me by looking at the equation where the y-intercept is going to be, how many solutions we can have. Also, these points here are called vertices, vertex. If it's a 3 here, subtract 1. We're going to have 2 of them. If it's a 2 here, subtract 1, we're going to have 1 vertex. The vertex is the highest or lowest point of a curve. It's the highest or lowest point on a curve. That's a vertex. And it's always going to be 1 less than the exponent. Or the highest exponent, I should say. Radicals. Whenever you hear say radicals, I mean square roots or any type of roots, square roots, cube root, whatever. What do we know about square roots? Can you take a square root of a negative number? No, because whatever is inside here, like the reason square root of 4, what is square root of 4? Why is it 2? Because 2 times 2 equals 4. So that's the reason we cannot have a square root of a negative number. Negative 2 times negative 2 is not negative 4. Positive 2 is not negative 4. So you can't take a negative. So the smallest it can be is 0. When x is 1, y is 1. When x is 4, the square root of 4 is 2. When x is 9, it's 3. So the radical looks like this. So what's the domain? What's the smallest x value I can have? 0. What's the largest? Infinity. So it's bracket, because I can use 0. How about my range? What's the lowest it can go? 0. And the highest? Infinity. Because remember, you cannot have a negative number. A cube root. The reason this is called a cube root is because there's a 3 right there. What that tells us cube root of 8. So what number times itself 3 times equals 8? 2 times 2 times 2 is 8, so it's 2. What number times itself equals negative 8? Negative 2. Negative 2 times negative 2 is positive 4. Times negative 2 is negative 8. So now we can see our x's can be positive or negative. If it's 0, it's 0. If it's positive, it looks like that. And if it's negative, it looks like this. So our x's can be positive or negative or 0, and our answers can be positive, negative, or zeros. So what's my domain and range? Yeah, the domain, since it keeps on going both directions, it's negative infinity to positive infinity. Likewise with the range. I can keep on going up and keep on going down. Negative infinity to positive infinity. The rational, the ratio, it's a fraction. Or we call them inverses. The reason we call them inverses is because this is the opposite of another function that we have. We'll get to that later on. We'll talk about inverse functions. Now, whenever x is on the bottom, what happens to y? The bigger x becomes, what happens to y? Does it get bigger, smaller, or 0? It gets smaller. Because when we start 1 over 1 equals 1. 1 over 2 is 1/2. 1 over 3, 1 over 4. You notice the bigger the bottom number gets, the smaller the overall thing is. So what this thing says, it looks like this. The further it goes out, the smaller it gets. Same if x is negative. It looks like this. That's the graph of 1 over x. If x is positive, the answer is positive. X negative, the answer is negative. Now the domain range change. We'll talk about these. Because you have x on the bottom, the rule of math says you cannot have 0 on the bottom. That's called an asymptote. We'll talk about that later on. So notice the domain goes from negative infinity all the way to 0, but doesn't go to 0. This line never touches. It goes from negative infinity to 0, never touches. Then it goes from 0 to infinity, but it never touches 0. We have to put a union there because it could be either here or here. It goes all the way up to, but doesn't touch the 0 line. And it starts at 0, but it doesn't touch it. The range is the same thing. It goes from negative infinity all the way up to 0, and then from 0 to positive infinity. So it's the same thing. Same equation, but this time x is squared. This time x is squared. What does that tell us? What does that make it the equation? If the x is squared, what happens? Oh yeah, we're gonna have two solutions, but our answers can never be negative. Because if I have a -3 in here and I square it, what happens to it? becomes positive 9. So whenever you square something, it always becomes positive. So the difference between this one and the previous one is this one can always have to say negative. I call that the Atari function. So my domain is the same as earlier. It goes from negative infinity to 0 and 0 to positive infinity. But my range changes now. I cannot have negatives, so this one's strictly from 0 to positive infinity. It can only go upwards. Exponential. So this is something like y equals 2 to the power x. The difference here, again, this is a whole section we're going to talk about with these, but the variable now is an exponent. All the other times the variable was the number we're dealing with. This is now an exponent. So we'll learn this stuff. So I'm just give you the graph of this one. It always crosses through 1. The domain and range. The domain is from negative infinity to positive infinity. So it's all real numbers. So we go from negative infinity to positive infinity, keeps on going. What's the range? Zero to infinity. But we cannot use 0 because it never touches. This number can never equal 0. The logarithmic equation, the logarithm, is an inverse of this one, which means I flip it around that. This graph will look like this. It always crosses through 1. So the domain is from 0 to infinity. But the range now goes from negative infinity to positive infinity. And really quick, let me do the last one for you. And these, in high school, you might have called them the parent functions, but if you ask me, there's only 2 parents. This is the library of functions. In the library, you have thousands of things. So these are the basis of all functions that we deal with. The greatest integer function. It says this: if you have a decimal, you just cut it off. What it says here is this. Let's say I had 1.75. That number's there. If I get rid of the decimal, I get 1. So that's where that line's there. So in other words, if you have a decimal on the x, you round it up or round it down. We round it out, just cut down take off the decimal. So if from 1.0, which is here, 1.1 is 1, 1.2 is 1, 1.3, 1.9 at 2.0, it comes up here at 2. Well, again, we're gonna talk about that later on. The domain and range of this one. The domain of this function are all the integers. It's not the negative to the positive infinity because it's not real numbers. There are no decimals here. It's only the integers, which we'll call n. And I'll give you the list of all the symbols we use for integers, whole numbers, real numbers, complex numbers, rational numbers. The range. No, I'm sorry. The range of the integers, I'm sorry. The domain is negative infinity to positive infinity. I'm sorry. Because it goes from negative infinity to positive infinity. It's just the output. The y's have to be integers. I'm sorry. I was trying to hurry up, trying to finish in 10 seconds. So over the weekend, we finished everything up to sections 1, 2, and 3. We didn't get 4 and 5 done, but we'll do that next time, as well as the inequalities. Memorize these. Because the faster you know these, the easier the rest of the semester will be for you. Because once you have these memorized, it'll help us when we do all of chapter 2 and chapter 4. All right, everybody, have a great, safe weekend. And I